Okay, this is lesson 1.2 on functions and graphs. This is to remind you, this lesson is used to remind you of what a function is and some of the properties. What does it mean to be an even function and what does it mean to be an odd function? All right, so a function is from a set domain, D is domain, to a set R, that is a rule that assigns a unique element in the range to each element in D, in the domain. So that, in a sense, in more simpler words, it means that your domain cannot be repeated. So you cannot have two of your x's being assigned to the same y there. So you can't have 1, 2 and 1, 3. But you can have two of the same y. So you can have 2, 1 and 3, 1, right? So you can have a nice flat line, but not a vertical line. That's exactly what it's trying to say. All right, so a function f of x, again, I'm losing my parentheses, so bear with me. Function f of x, it is even if any negative x you plug in gets you the same value as you plugging in as for the positive x, right? So when you're plugging in -2, you get the same value as you plug in a +2. So for example, a parabola is a beautiful even function because when you plug in -3, you get the same value as you plug it in when you plug in +3, right? So you have a symmetry with respect to the y-axis, right? An odd function is when you plug in the negative x, you get the same value but a negative value outside. So again, that sounds a little crazy, that sounds a little convoluted, but what does it mean? It means that, for example, if you plug in a +2, you get a +8, but when you plug in a -2, you get a -8, right? So the negative is on the outside. So a cube function is a very good example of what an odd function looks like. So a parabola is even because both of them are the same. An odd function, it means that all the values here on the right-hand side now gets flipped around and has symmetry with respect to the origin and has its counterpart in quadrant 3 like so, all right? So that these two are typical examples of odd and even function. So the main point of today is to remind you of how to graph functions. There's some parent functions involved here. You want to look for domain, you want to look for a range to remind you what domain and range is, and then you determine whether or not there is symmetry in this function. Okay, first equation to do is f of x equals 4 minus x squared. So first thing I always remind students to do is to kind of create some scales on your graph here, because when you don't have the scales, it's very hard to count every single box. So I typically count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 5. I typically label the 5s so that it's a lot easier for me to locate my points. All right, so now remind yourself, 4 minus x squared, what does that mean? 4 means that you really want to read this as -x squared plus 4, because the 4 means there's a vertical shift of 4, so the entire graph shifted up 4. So my parabola, instead of being here, it's going to go 1, 2, 3, 4, and go up right this way. But because it's -x squared here, it's going to roll my parabola down this way. All right, so that gives you an idea of what to expect and what to do on this graph. So you go up to +4, and instead of bowling your parabola up, you're going to bowl down. So 1 squared is 1, -1 squared is 1, 2 squared is 4, -2 squared is 4, right? And then 3 squared is 9, -3 squared is 9. So this is a pretty good depiction of my parabola. Okay, all right, now what's next? You need to talk about your domain and range. So what is the domain here? Well, the domain here is going to go out to infinity this way and go out to infinity this way when you zoom out further and further of this graph. The domain is going to be all reals. Another way to write all reals is in interval form, -infinity to infinity. Remember to open your brackets in terms of using parentheses, because we cannot include our infinity. There's no ending to infinity. Okay, what about range? Well, this parabola, the highest it goes is up to 4, but it goes all the way down to -infinity. So another way to write this is you can write y is less than or equal to 4, but start practicing using interval notation. This goes from -infinity up to 4. You do not include a -infinity, but you do include the 4 because it is closing up at the end point. Okay, so that is your domain and range. Let me see if I answered everything. So I drew its graph. That's part A. Part B, find the domain. C, find the range. And then D, it says determine symmetry. Now, of course, if you look at the graph itself, you say, oh, there is symmetry. The left and right side are the same. They are symmetric with respect to the y-axis. This is an even function. But how do you prove that? How do you determine that? You plug in negative x into your function. So when I plug in a negative x into this function, I get 4 minus negative x squared, right? So keep in mind that negative x squared is negative x times negative x, which still makes it x squared. So notice that when I'm done with this, my equation here is exactly the same as my equation up there, even though I plugged in negative x instead of positive x. So when you get the same exact function back, you have an even function. Hence, this is symmetric with respect to the y-axis. Right, and so you can use any of these shorthands that I am using here in our notes here when you write it out in your tests and quizzes. Okay. All right. Next equation is f of x equals negative 3 cube root of x. So again, look at this as negative 3 times the cube root of x. If you recall what the cube root of x looks like, it looks like an s function, like so, right? So what is it going to do? Sometimes it's actually much easier if you kind of create a t-table for yourself and to see what this looks like. So I know that if I cube root of negative 8, I get negative 2. If I cube root negative 1, I get negative 1. Cube root 0, 0, 1, 1, 8, and 2. Why am I doing that? Because now this negative 3 is going to affect all my y values because it says f of x equals y equals. So that coefficient actually multiplies all the y values of this graph, right? So then what we're going to do now is going to go ahead and take the negative 3, multiply the y value, so I get 6, 3 is still 0, so I'm just going to cross it out, and then negative 3 and negative 6. Okay, now I can go ahead and graph this function out, right? So 1, 2, 3, 4, 5. I always put out my 5s so I can have my equation. Okay, all right, so negative 8, positive 6 is right here. Negative 1, positive 3, 0, 0, 1, negative 3, 8, negative 6. All right, so what is this going to do? It's going to look something like, let me turn this so it's a little easier to draw. So it's going to go like this, curving this way, and curving like so for my graph. Okay. All right. So why is this important? Once you graph the function, typically we can see the domain from the equation itself because there is only a few functions out there that the domain is going to have issues with, and we'll talk more about this in the months to come. But for range, it's actually typically much easier to just graph out the function and then look at the behavior of it. It's actually a lot harder to solve for algebraically. All right. So part A says to graph the function. We did that. Part B says domain of this. Well, domain of this looks like it's going out to infinity and out to infinity. So it's going to be negative infinity to infinity, which is the same for this function for the range. Negative infinity to infinity because it's going to go up to positive infinity and down to negative infinity. Right. All right. Part D, what kind of symmetry does it have? Well, I'm going to plug in a negative x, right? So it's going to be negative 3 cube root of negative x. Well, because it's a cube root, I am able to cube root the negative x. I'm able to take the negative out. So it becomes negative 3 times negative cube root of x. So I know this is going to look really weird, but if you take this negative outside, right? And hence you have negative of negative 3 cube root of x. You have your original function here with an extra negative out here, hence making this an odd function, right? So that's what odd function means. It needs the original function and you're able to factor out a negative on the outside. So this is an odd function, which then tells me there's symmetry with respect to the origin. So that's the symmetry for this one, okay? All right. Next, remind you what this is. This is a square root function. So if you recall, there are some translations here, right? The -1 and the 2 does a little bit something to our function. So a square root function typically starts at 0, 0 and goes out like this, right? So what does the -1 do for us? So reminding you that when it's in parentheses, when it's inside your square root, it has the opposite behavior than what we think. This -1 actually moves it to the right one. So this is a right 1 shift. And then this 2 on the outside makes it up 2. So this original point is now going to, instead of being at 0, 0, it's going to be at 1, 2. So Again, I still count my 5s, so it's a little bit easier to see my scale. Okay. And then my point is going to be 1, 2. Since there's no coefficient in front of the square root, my square root is going to have the same t-table as it normally does, which then tells me I get square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So that would give me my square root function this way. All right. So again, this is actually making it much easier to figure out my domain and range. My domain is looking like it's starting from this point and on, right? So that point is my 1. So it's going to be 1 to infinity. My range looks like it's going to go from this point and on. So my range is going to be 2 infinity. All right. Now, symmetry. Does it have symmetry? You can look at this graph and say, no, there's no symmetry. But again, how do I prove it? Okay, so I'm going to show you how you prove this, and I need a little bit more room than that. So I'm going to go ahead and do that here. So f of negative x, and you plug in negative x, you get 2 plus root negative x minus 1. Okay, so notice that there's a negative I can take out of both of them, right? And so that would be negative x plus 1 like so. This is a square root. You can't really factor out the negative. You can keep the negative in there because just in case that this is a negative value, the negative will actually cancel the negative, so it's okay to leave the negative inside. But what I'm trying to point out is then this function is not the same as the original function at all, right? So first of all, that tells me it's not an even function. Secondly, I'm unable to take that negative all the way to the outside of the function, hence this is not an odd function either. So it's neither odd nor even, so there's no symmetry, right? If it's neither odd nor even, there's no symmetry in this, okay? All right, last but not least is a piecewise function. It's reminding you of what piecewise function is from, I don't know, a while back. So what I typically tell students to do is to make sure they're able to erase these if you are not comfortable with it yet. If you are comfortable, you don't have to do the erasing. You just need to draw in the part you want. All right. So first thing I do again, to make my scale visible. All right. So first one is x squared. So an x squared is a parabola. Notice I'm trying to put my points down already, right? And I get my parabola like so. However, I don't need all of it. It only wants to the left of the 0. So x is less than 0, and it's an open circle there. So from the 0, I'm going to connect my parabola, and that's only the side I want. And so I'm still doing some erasing because I don't need those dots there. Okay. Next, x cubed minus 1. So x cubed looks like this. Minus 1 says instead of 0, 0 here, I'm going to go down 1. So instead of 0, 0, I'm going to go down 1 right here. And then it says I want to graph from 0 to 2. So that means that I got 1 cubed is 1. 2 cubed is 8. So if I count 1, 2, 3, 4, 5, 6, 7, 8. And both endpoints are closed in. So even though this is a cube function, it's going to look like kind of like half of a parabola because it's only half the right half of the cube function. Okay. All right. Last one. I like to use colors to kind of show you the different ones, so you can follow along with colors, or you don't have to. You have 2x minus 1. So 2x minus 1 in this case is actually much easier to go ahead and graph the whole thing out. If you don't want to, you can actually go ahead and graph out the point here. So what I usually do is I go ahead and put the point in there, plug it in. I get 2 times 2 minus 1. So that's 3. So my point is at 2, 3. So 2, 3 right here, open circle here. And then the slope is 2. So from that point up to right 1, up to right 1, up to right 1. And my graph is going to look something like this, right? So you could have drawn this out and then draw it from the y-intercept of -1. But then that does require a bit of erasing, and it might erase into what you just did before. So I recommend doing it this way. Okay. All right. Hopefully that's a good review of how to graph functions and some of the relationships with function. Okay. That's it.